Good morning, all of you. Today we are going to consider another method for calculating the correlation that is Spearman rank correlation coefficient. See, in many real life situations, especially in the field of education and other social science subjects, see the data we collect are not purely numerical, or it may be difficult to measure numerically. For example, if you want to study the relationship between the student leadership qualities and class participations, it is very hard to assign a exact numerical value for these traits. In such a cases, see Carl Pearson's coefficient of correlation cannot be used since we are already assumed in the case of a Carl Pearson's coefficient of correlation that is both variable are quantitative in nature and the relationship should be a linear. So to handle such a qualitative data, or what we can say that generally we are going to use a ordinal data in the case of a Spearman rank correlation there, observation can be ranked, that is first rank, second rank, third rank. Then the Spearman rank correlation is used. And here it allows us to measure the strength as well as the direction of the relationship based upon the rank rather than the actual numerical value. So the Spearman rank correlation method, which was developed by, it was Charles Edward Spearman, a British psychologist in 1904. See, he introduced it as a way to measure the relationship between the ranking rather than a precise numerical value. So his goal was here to study the relationship between the psychological and behavioral data where the ranking is more meaningful than the exact measurement in terms of numerical value. So the Spearman rank correlation, see here it is, we are considering the non-parametric statistics. It is considering as a part of non-parametric statistics, which means that it does not assume normal distribution or it does not require any type of numerical data. It can be used when the data are from the ranks or can be converted into the rank. That means the normal data can also be converted into the form of ranks. So it is especially useful when the Carl Pearson's coefficient of correlation that cannot be applied because it assumes, that means Carl Pearson's coefficient of correlation assume the linearity as well as the quantitative data which is required for the Carl Pearson's coefficient of correlation. So here, see, unlike Carl Pearson's coefficient of correlation, see, in the case of a Spearman rank correlation, which is used for the qualitative data, that means the categorical data is considered, especially in the case of a Spearman rank correlation. So that means in the case of a Spearman rank correlation, when the variables are qualitative or it may be a categorical, that means it can be a ranked data. For example, the ranking of the students based on the performance, that is first rank, second rank, and so on. And accordingly, it measures the strength as well as the direction or the association between the two variables set. So we can accordingly find out the direction as well as the strength of relationship between two variables. Okay, and it is generally denoted by a Greek letter rho. It is rho which is used here, and we are assuming again here also the rho which is lies between -1 and +1, where -1 which showing that there exists a strong negative relationship and +1 which near to the +1 value which shows that positive or relation between the variables. See, when we can use the Spearman correlation, see, it helps to understand how closely two sets of ranked data are moved together. That means it measures how closely two sets of rankings correspondence. It shows whether higher rank in one variable tends to match with the higher ranks of another variable, that means positive or positive correlation, or maybe with lower rank in terms of negative correlation. So here, when the data are in the ranked format, when the data sets are ranked format rather than the numerical forms, see, many of the times we don't have exact measurement, but we can make it in a ranked format. For instance, see, ranking the job candidates based upon their performance. In such a cases, Spearman rank correlation can be ideal because it works directly with the ordinal data. See, here when the relationship between the variable is monotonic. That means, what do you mean by a monotonic relationship? A monotonic relationship means that, see, one variable is increases, then other either consistently increase or consistently decrease. It does not have any straight line. This method can capture a curved but consistently increasing or decreasing trend. For example, the education level. See, as your education level increases, the income generally increases, though it is not always linear. But at the same time, both variables are increased together. And here, when the data are not normally distributed or it contain, outliers, see, it is a non-parametric test called, Spearman correlation. It is a non-parametric test. It does not require any normal distribution. And it also less affected by the extreme values or the outliers because it works with the rank instead of the, actual value. We are going to consider the ranks. So even if few observations are very high, that means the variables are outliers or it is very low. See, they do not distort the, the results of correlation significantly. Then it is commonly used in the, social science, education, psychology, as well as the behavioral science. Especially in the case of a psychology, it is ranking the personality traits or testing the scores. Especially in the case of education, comparing the students' ranks across the subject. In a behavioral studies, for example, you want to measure the preferences, opinion, reaction of the people. All this can be generally come under the ordinal data set, and accordingly, it is better to use the Spearman rank correlation for finding the relationship. Now, see, the Spearman rank correlation can be calculated by using the formula that is rho, which is equal to 1 minus 6 into sum of d square whole divided by n into n square minus 1. See here, what is d? D is the difference between the pairs of the rank of the same individual in the two characteristics. So it is the difference between two ranks, and n is the number of observation. And accordingly, the Spearman rank correlation also, it is lies between -1 as well as the +1. So by using this formula, we can calculate the Spearman rank correlation. Now, let us consider one example. See, calculate Spearman rank correlation coefficient between advertisement cost and sales activities. So, advertisement cost is given here and the sales activities are also given here. We want to calculate, Spearman rank correlation. Since the actual value is given here, we want to arrange these actual values in the form of ranked. So, here advertisement cost I have denoted in terms of X, and the sales I have denoted in terms of Y. See, the ranks of X. See, the highest value which I am giving here with the first rank, so it is 98 is ranked 1, then followed by 90 the second rank, then the third rank is 82, then the fourth rank is 78, and the fifth rank is 75, and so on up to, see, we have a 10 observation. Similarly, here Y also I am going to rank by assigning the highest value, that is 91 is 1, and then followed by 86, which is the second rank, and then 84, which is the third rank, then 68 is the fourth rank, then 62 is the fifth rank, and accordingly the remaining values also. Since, see, all the actual value I have converted in the form of a ranked data, so it is a ratio scale data. Now what we are going to do, we are going to find out the difference between these two ranks in terms of D. See, I am denoting here it is D, which is equal to difference between X and Y. So it is difference between two ranks. So it is 8 minus 10, which is equal to -2, 6 minus 8, which is equal to -2, 7 minus 7, which is 0, and accordingly the remaining values also. And if you go for summing up all these D, then it is equal to 0. And we are going to then square the each term. So it is -2 square, which is equal to 4, -2 square again it is 4, and so on. And the sum of D square, which is equal to 30. Since the sum of D square is equal to 30, we can now apply the formula for calculating, the Spearman rank correlation, which is equal to 1 minus 6 into sum of D square divided by n into n square minus 1. Since sum of D square, which is equal to 30, and n is equal to, it is 10 observation, we can just substitute all these things here. It is 1 minus 6 into sum of D square, which is equal to 30 divided by n, which is equal to 10 into 10 square minus 1. See, we can simplify it. See, it is 10 square is equal to 100, so it is 100 minus 1, and 6 into 30, which is equal to 180. Then 100 minus 1, which is equal to 99, into 10, which is equal to 990. Then 1 minus 180 divided by 990. So the ratio of these two terms, which is equal to, it is 2 by 11. So 1 minus 2 by 11, which is equal to 9 by 11. And accordingly, the value of correlation is equal to 0.82. That means there exists a strong positive correlation between the advertisement cost as well as the sales activities. Now, another example, see, the ranking is given by two judges is given here. 11 contestants are given here from, see, A to K contestant are here, and the rank which is given by the judges 1 and 2 is also mentioned here. Since the rank is directly given here, we just want to calculate the difference between these two ranks, and accordingly we are going to square it. So the contestant A to K is given here. Then R1 is also given, R2 is also given here, since it is the rank which is given by two separate judges. Okay. Now the D which we are going to calculate here, that is the difference between R1 and R2. So it is 1 minus 2, yeah, absolute value we are going to consider, it is 2 minus 1, it is 1. 3 minus 2, which is equal to plus 1, 1 minus 3, which is equal to minus 2, and accordingly the difference between these two ranks, that is R2 minus R1, which I have calculated and denoted in terms of D, then we are going to square the each difference, that is 1 square, which is 1, 1 square, it is again come out with 1, minus 2 square, which is equal to 4, and so on. And the sum of D square, which is equal to 20. If you go for adding up all these terms, it is come out with 20. So this is the sum of D square. Now, since the sum of D square is already available, we can apply the formula for calculating the Spearman rank correlation, which is equal to 1 minus 6 into sum of D square divided by n into n square minus 1. Since n is equal to 11 here and sum of D square is equal to 20, just we are substituting here in the given formula. So it is 1 minus 6 into sum of D square, which is 20, divided by n, 11 into 11 square minus 1. So what is 6 into 20, which is 120, then 11 square, which is equal to 121. 121 minus 1, which is equal to 120 into 11, which is equal to 1320. Then the ratio of these two, see, it is 120 divided by 1320, which is equal to 0.0909, and 1 minus 0.0909, which is equal to 0.9091. See, there exists a strong positive, since it is nearer to the closer to the plus 1, there exists a strong positive linear relationship between, these two variables, these two ranks. Okay. Now, another example which is given here, in the marketing survey of the price of tea and coffee in a town based on the quality was found as shown below. Could you find any relationship between tea and coffee price? So the price of tea and price of coffee is given here. See, since it is the actual value, we want to find out the ranks. Okay. So here the price of tea, which is given here, and the highest price which I have given the first rank, followed, see, it is, that's why 95 is ranked 1, then followed by 90, which is second rank, 88 third rank, then 75 is fourth, then 70 is fifth, and so on. Similarly, the price of coffee is also directly mentioned here. We want to calculate it again. We want to rank it here either ascending or descending order. Since I have given the highest value 1, then see, 150 is equal to 1. The second rank is 140. Then third rank is 134. Fourth rank is 120, and so on. So since we have already arranged the ranks here for the price of tea as well as the price of coffee, now we are going to calculate the D, that is the difference between two ranks, that is 4 minus 3, which is equal to 1, 3 minus 2, which is equal to 1, 1 minus 1, which is 0, 5 minus 5, which is equal to 0, 6 minus 6, which is equal to 0, 2 minus 4, which is equal to 2, then 7 minus 7, which is equal to 0. So either you can take the difference between rank 2 and rank 1, or you can also take the rank 1 minus rank 2. Since D value we are not going to assess anywhere, rather we are going to square it. So either it is minus or plus, doesn't matter, because we are going to square the each term here, it will become a positive value. So 1 square is equal to 1, 1 square again 1, 0, 2 square which is equal to 4, and the sum of D square which is equal to 6 here. Since sum of D square is already given and the n What is n here? 2, 4, 6, 7. 6, 7 is the n. So we can directly substitute these values in the given formula. So 1 minus 6 into d, which is equal the sum of d square, which is equal to 6, divided by n, which is equal to 7 into 7 square minus 1. See, what is 7 square? Which is equal to 49. 6 into 6, which is 36. So 49 minus 1, which is equal to 48 into 7, which is 336. So 336 divided by 336, which is equal to 0.1071. Then 1 minus 0.1071, which is equal to 0.8929. That means, again, here also there exists a positive relationship between the price of tea as well as the price of coffee as well. Okay. Sometime in the real world situation, it is common to find two or more items with the same value. Means that two or more observations have exactly same value for the variable. See, what to do in that particular case? See, this is situation which is generally called it is ties, and it need to handle very carefully to ensure a accurate result. See, since their values are equal, since it is two or more values have the same values, then it is little bit a difficult task. We should very carefully, calculate the correlation to get a accurate result. Since their values are equal, it would be, leads to the what we can say that it is unfair to assign different ranks to them. That means its variation. That means the same rank will affect the correlation coefficient. So here the tied ranks reduce the variation among the ranks. That means the effect of tied ranks when the ties occurs, that means repeated ranks are occurs, then the variation among the ranks is reduced because several ranks become the equals. So this leads to the slightly distorting correlation value. It will distort the correlation value. We want to introduce a new factor which is known as a correction factor that should be used to adjust this particular effect. See, without correction factor, what is the problem? The computation of correlation coefficient might slightly underestimate or maybe overestimate the true relationship between the variables. So the correction factor we should introduce, and accordingly this correction ensure a fair treatment of the ties observation and maintaining a validity of the result. So once again I am repeating, that is the ties are nothing but if we have two or more items have the same value, same equal values or equal ranks, then ties will happen, and accordingly it reduce the variations in the ranks, and that's why it distort the correlation coefficient. So we want to correct it. So that's why we want to introduce a correction factor. So in such a cases, we assign a average rank here. Here we are going to, how we are going to correct it? By calculating a average rank to that those items would have the same ranks. For example, see, we have two students, both scored 70 marks. So here these corresponding rank to the 5 and 6, for example, 5th and 6th rank is 70 marks. Then at that particular case, it will distort the correlation coefficient, and accordingly what we are going to do, we are going to calculate the average value, that is 5 plus 6 divided by 2, that is 5.5. So for the both candidate, we will give the value of 5.5. So whenever your data set include this type of ties ranks, apply the correction factor to get an accurate value for the Spearman rank correlation. So even though the changes is very small, it ensure the statistically precise and avoid the overestimation as well as the underestimation of the correlation coefficient. We will consider some examples so that it will be more clear. See, what is correction factor? See, the correction factor, that is if each group ties, what are the various values for each variable where the ties are come out, that means same ranks are come out, then the correction term should be applied. And the correction term is, it is 1 upon 12 into mq minus m. See here, what is mq minus m, which represent how much variation lost due to ties among the m equal items. Okay. So here 1 upon 12, and this 1 upon 12 is the just scaling constant which is used to keep the correction on the same scale as the rank difference. So the total correction factor here, M is nothing but it is the number of item which ties ranks. So if there are several groups in a particular example, if we have a several group ties, then we want to apply the each correction factor for the each group, and accordingly we are going to sum up. Okay. So accordingly, for example, if we have 3 tie ranks are there, then the formula will become, see, the rho is equal to, that is R is equal to, correlation is equal to 1 minus 6 into sum of D square. This is earlier also there. Plus, we are going to sum up. See how many times the ties are happened here? 3 times. That's why we introduced 3 correction factors. So by using these correction factors, we will get an accurate as well as fair result. That means correlation relationship between the variables, even when the ranks are not perfectly distinct. So in short, what we can say that the ties are quite common in the real data, and especially the social science, especially in the education also. Ignoring them can slightly misrepresent the strength as well as the association of the two variables. So we should introduce this type of correction factor and accordingly modify the formula and then calculate the correlation coefficient. Now let us consider some examples so that it will be more clear. See, one example is given here. A study is conducted to examine whether there is any relationship between students' attendance percentage and their internal assessment marks. So attendance percentage is denoted in terms of X and the internal assessment marks are given denoted in terms of Y of the classes of 10 students. Okay, so accordingly the 10 students, their attendance percentage as well as their assessment test, their internal assessment marks are also given in terms of X and Y. Now first, since it is already given here the variable X, see, first what we are going to do, we are going to rank it. See, highest value which I am going to give the first rank, so 55 I am denoting in terms of 1, followed by 47 which is 2, then 40 which is 3, then 30 which is 4, and so on the remaining ranks as well for the variable X. And for the variable Y also I am going to rank here. See, the highest value which is given here, see, highest value which is 20 here, so it is given first rank, followed by 15 which is 2, then the third one which is 14. See, in between that there are some problems. See here, 6 is repeated thrice here. 6 is repeated thrice. See what happened in this particular case. When we have 2 or more values are equal, they share the same rank. Then each will assign the average rank. See here in the case 6, it is the 7th, 8th, 9th rank. 6, 6, 6, 6. 3 times 6 is repeated. So 6 will be come out with 3 times. So it is the 7th rank, 8th rank and 9th rank. So what I am going to do here, instead of citing it is 6th, 7th, 8th, 9th, I am going to calculate the average value here, that is 7, 8, 9 divided by 3, since we have a 3 values here. So 7 plus 8 plus 9 which is equal to 24 divided by 3 which is equal to 8. That's why, see, for the variable, see, the value 6, 6, 6, see, I have given the rank 8. We will not have 7, 8, 9, rather we are only denoting in terms of 8, that is average rank which we are going to assign here. Similarly, here also, see here, the 8 is repeated twice. 8 is repeated twice in the Y category. See, it was 5th and 6th rank. It was 5th. One is 5th and another one is 6th rank. See, instead of that, instead of 5th and 6th rank, what I have calculated here, 5 plus 6 which is equal to 11 divided by 2. Average rank I have calculated. So accordingly, it is 5.5, 5.5. Both will be assigned the equal rank, average rank, that is equal to 5.5. Here again, see, 1 is repeated. See, 1 was, it was 8th rank and this was the 9th rank. Okay, so that's why, see, instead of denoting the 8th and 9th rank, what I have done here, I have added the 8th and 9th which is equal to 17 and calculated the average which is equal to 17 divided by 2 which is equal to 8.5. So for the 1 here also I have assigned 8.5 and here also I have assigned 8.5. Now, by using these ranks, see what we want to do, we want to calculate the difference between these two ranks. So here the difference between two ranks, it is 5.5 minus 3, which is equal to minus 2.5, 5.5 minus 5, which is equal to minus 0.5, 1 minus 4, which is equal to 3 or minus 3, then 8.5 minus 10, which is equal to 1.5, then 4 minus 8 minus 4, which is equal to 4, and so on. You can calculate the difference between these two ranks. Minus plus, which does not matter here, since we are going to square the each values of the D category, we are going to square it. Since whether it is minus or plus sign, it will become a positive value. So here, see D square, which is equal to 2.5 square, which is equal to 6.25, 0.5 square, which is equal to 0.25, 3 square, which is equal to 9, 1.5 square, which is equal to 2.25 square, sorry, 2.25, 4 square, which is equal to 16, 2 square, which is 4, 1 square, which is 1, 1 square, which is 1, and 0.5 square, which is 0.25, and minus 1, that is square, which is equal to, again come out with 1. So we have a D square also. So the sum of D square, if you go for summing up or adding up each term's values here, then it will become sum of D square, which is equal to 41. So the sum of D square is equal to 41. See what we are actually did here. See, you keep in mind again, if we have any repeated terms or repeated ranks are there, then we have to calculate the average rank, and then accordingly we have to calculate the difference between two ranks. Okay. Now see, since we have three corrections which we were done here. See, in the case of an X category, we have one correction, and in the Y category we have two correction. In the X category, 6 was repeated thrice, so we have one correction factor I am introducing here. Similarly for Y, we have the variable Y category also, we have two terms, two values which is repeated. One is 8 is repeated and another one is 1 is also repeated, but we have only two values. So here, since this is the formula for calculating the Spearman rank correlation by introducing the correction factor. Okay. And now we can substitute here what actually we are calculated, sum of D square, which we are already calculated, which is equal to 41. Then 6 into 41 plus 1 upon 12 into m cube. See, here in the first m, I am denoting that is, you just recall it, in the X category, 6 was repeated thrice. That's why m will become 3. Again, since 6 is repeated 3 times, here m will become 3. So it is 3 cube minus 3 plus 1 by 12 into m cube. Here it is 2 cube. Why? In the Y category, 8 was repeated twice. So 8 was repeated twice. That's why m will become 2 here. So it is 2 cube minus m again 2 plus 1 by 12 into, it is m cube again 2 cube. Why? Because in the Y category, 1 was repeated twice. So since it is twice, the m will become 2. If it is thrice, m will become 3. If it is 4 times, then m will become 4. Okay. So that's why the m is differing from here, and divided by n into n square minus 1. So since here n is equal to 10, so it is 10 into 10 square minus 1. Now we can simplify it. See, it is r is equal to 1 minus 6 into 41 plus 1 by 12 into, what is 3 cube, which is 27, minus 3, which is 24. 24 divided by 12, which is equal to 2, plus 1 by 12 into, what is 2 cube, which is 8. 8 minus 2, which is equal to 6. 6 divided by 12, which is equal to 0.5. Again, 1 by 12 into 2 cube minus 2, that is, what is 2 cube, which is 8. 8 minus 2, which is equal to 6. 6 divided by 12, which is equal to 0.5. So that's why in the numerator, 6 into 41 plus the simplified version of this term, which is equal to 2, and for this it is 0.5 and also 0.5 divided by 10 into 10 square minus 1. It is 10 square, which is 100 minus 1, which is 99, into 10, which is 990. Okay. Now again we can simplify it by adding all these terms. So it will become 41 plus 2 plus 0.5 plus 0.5, which is equal to 44 divided by 990. So it is 6 into 44 divided by 990, which is equal to 0.2667. 1 minus 0.2667, which is equal to 0.733. So here it is a positive value, which means that there exists a strong positive relationship between these two variable, that is x and y. Okay, so we are calculated the correlation coefficient here by introducing the correction factor. One more example we are going to consider here. See, we are going to consider one example, that is coefficient of rank correlation between mathematics and statistics. That is, the marks of 10 students was found to be 0.5. See, the correlation was 0.5. It was later discovered that the differences in the rank between two subjects obtained by one of the students was wrongly taken as 3 instead of 7. So we want to find out the correct value of correlation. So what are the information which is given? Since this is the formula for calculating the Spearman rank correlation, it is 1 minus 6 into sum of d square divided by n into n square minus 1. See, what are the information given here? R is already calculated there, which is equal to 0.5. They are calculated value of correlation which is equal to 0.5, which I have denoting, instead of using R, I am denoting in terms of 0.5. 1 minus 6 into sum of d square. Sum of d square is not given there, so we want to calculate here. Since the information which is given, that is, it is related to the 10 students, so n is equal to 10. So 10 into 10 square, which is 100 minus 1. Okay, see here, what we want to do, we want to recalculate the correlation coefficient. Earlier it was calculated as 0.5. Now again we want to recalculate this particular correlation value, because one of the rank differences which we are considered here, which was wrongly taken as 3 instead of 7. So now we again wants to recalculate sum of d square, sum of d square. So sum of d square, which we wants to calculate here also. So here we can simplify it. 10 into 100 minus 1, which is equal to 990. Now this term I am going to take into the right side, so it will become minus 6 into sum of d square divided by 990 will become plus, which is equal to 1 minus 0.5 I am going to take into the right side, so it will become minus 0.5. So here the sum of d square divided by 990, which is equal to 1 minus 0.5, which is equal to 9.5. Then denominator I am going to take into the right side, so it will become 6 sum of d square, which is equal to 0.5 into 990. So the 0.5 into 990, which is equal to 495. Then this 6 I am going to take into the right side, so it will goes to the denominator side. So 495 divided by 6, which is equal to 82.5. So the sum of d square, which is equal to 82.5. Now what we want to find out? See, now we want to calculate the correct sum of d square. The correct sum of d square, how we are going to calculate? See, it is the sum of d square, which is equal to 82.5 plus. See, we want to subtract the wrong value, and we have to calculate the original value. That means the right value. So it is right value is 7. So 7 square minus 3 square, we want to subtract it. So accordingly, 82.5 plus 7 square, which is 49, minus 3 square, which is equal to 9. So it is 122.5. So the correct correlation coefficient now we can calculate, that is 1 minus 6 into sum of d square, which is equal to 122.5 divided by 10 into 10 square minus 1. So it is which is equal to 1 minus the numerator term. If you go for multiplying it, it is equal to 735. Then 10 into 10 square minus 1, which is 99 into 10, which is equal to 990. So the ratio between these two, which is equal to 0.74. So 1 minus 0.74, which is equal to 0.257. That means the correlation now, instead of 0.5, the new correlation, the correct correlation is equal to 0.257. So this 0.257, which is nearer to the 0, that means there exists a positive relationship, but at the same time, the positive relationship is weak. Okay. Now we are going to enumerate what are the various advantages of the Spearman rank correlation. See, Spearman rank correlation coefficient offer several advantages and make it widely applicable in research as well as the data analysis, because it is simple and easy to calculate. It requiring only the rank of the data rather than their actual value, which make it particularly suitable when precise measurement are unavailable. That means actual numerical value is not available. So in that particular case, you can use the Spearman rank correlation. The method can be effectively used when we have the ranked data, or it is also known as ordinal data, where the variables are represented order rather than exact numerical quantities. See, another major benefit is that it is not affected by the outliers. Since we are already said that outliers are the extreme higher value or extreme lower value. Since extreme values do not distort the ranking process, see, it cannot affect the correlation as well. Okay. Moreover, see, it is well suited for identifying non-linear, but at the same time, for the monotonic relationship, where the variables moves in the same or opposite direction but do not necessarily at a constant rate. At that particular time also, we can utilize the Spearman rank correlation. And finally, the Spearman correlation, especially it is useful when we are dealing with a qualitative data that can be logically ranked data such as preferences, satisfaction, level of income, level of education, performance rating. In such a cases, making it a versatile tool for social science as well as education and behavioral researchers. So these are the various advantages of the Spearman rank correlation. So let me conclude here. See, in the last 5 lectures, we have discussed the concept of correlation, then methods for calculating correlation in terms of scatter diagram, in terms of Karl-Pearson's coefficient of correlation, where we have used different methods for calculating the Karl-Pearson's coefficient of correlation by using the actual value of the variable, the deviation taken from its mean, then deviation taken from the assumed mean, covariance method along with its derivation we have discussed in detail in the last 5 lectures. So of course, after that we discussed the Spearman rank correlation also. So entirely which type of correlation which we want to utilize, it's entirely depending upon the nature of data. In the next lecture, we will introduce another related concept which is known as regression analysis. So we will see in the next lecture. Thank you.